Alright, welcome. My name is Kome. Welcome to this tutorial of the functional programming challenge. Remember, we are 30% of our way up of the challenges. So let's look at the first challenge here, where you have to take or drop operations. So here, take the first n elements. You take the first n elements. So let's see how we'll do this. So we want to be able to take the first n elements and then of course leave the rest. So to do that, you come here and call array.slice and then of course you slice from 0 to n. So run this. Takes me to 2. So this other one is take while elements, or you'll be able to, it's a take while elements while predicate is true. So you'll be able to return elements when the predicate happens to be true. Take elements while predicate is true. So here I'm going to return true for the index first of all. So I'll say const index, maybe stop index. It should be given by array.slice and array.map, and then I will map through the array elements. So I'll call this value, and then the index, or simply put, I'll call array.findIndex. Let me use this, find index, and then of course I have the index, and I want to return the index where the predicate happens to be, though I passed in the predicate happens to be false, I want to return that at that point where the predicate happens to give us the false element, so that now we can come and slice it here all the way from 0 all the way to 1 element near the index or the stop index. So I'll run this. Moving to level 3. Okay, skip elements where predicate is true. Again, of course, you come here and declare const, I'll call it stop index, or skip elements. Let me call it start index. Start index. At what point will you be starting? You'll be starting when array.findIndex happens. Of course, you have the index here. Happens to give us the predicate. So you predicate when you pass the index, or the item, sorry, call it the item. This callback can have the item. So when we pass in the item, we expect to receive the result when that item happens to be false, so that it can start at that point. So the index at which the predicate will return give us false, we'll start slicing from there. So I'll return array.slice, and then I'll start from start index. I'll start from start index all the way to array.length. Now let me start from start index. Let's see what happens. Yes, all the way from start index going all the way. So let's go to the next challenge. We have to chunk arrays into size n. So of course you can see we have 1, 2, 3, 4, 5. We want to create chunks of 2, 2, 2, 2. So the first thing that we'll do here is we'll return, of course, we can return array.from, or we create chunks first of all, and we want to create chunks to store our arrays or sub-arrays whose length will be, or maybe the number of chunks will be given by the array.length divided by the size of each element, length, divided by the size of each array element. And then of course we want the math.ceil, so that if we have length n, I'm missing some n there, so n length, so you want to return the number of array elements, or maybe the number of chunks given. Of course we have the array length, the number of elements, divided by the size that will go to each, of the size of each subarray, so that you can get the number of subarrays. Let's, for example, we have 5 elements, then the length will be 5. If we divide by, let's say we want chunk 2, 2, then we'll be having 5 divided by 2, which is 2.5. And now we want the ceil of that is 3, because the 0.5 must also be stored somewhere. So having done that, then remember the array, this function, after now the length, so that is where we end the length. So length math.ceil, good. So here we have another callback that we can have here, which is the map function, and we are going to skip the value, but now we want the index, and then inside there we will do some mathematics. So inside there we will come and do our function. We will come and say array.now slice. We want to slice from the index all the way to the index, and then of course plus size, index plus the number, index plus size, array.slice index, and then index plus. Okay, index times size, because of course we want to know to slice from the first one. So index times size, index multiplied by size, and then index multiplied by size plus size, plus now the size, so that you can get the size of each element, of the size of each, so you can slice to the last element. Now skipping the all the way to the last element. Remember, the array.slice would slice, if you have to slice, let's say for example from 0 to 4, 4 will be skipped to go up to 3. So let's see what happens on this. Okay, there is a problem. Let's try to fix it. So here we are slicing index from index.size all the way to the index multiplied by size plus size. Would we have missed something? Yes, because this function here, you don't need to have this. You can do away with this, so it becomes just a single expression like that, so that you can just run. Good. Moving to level 2, chunk with overlap. This is the sliding window. So what the sliding window does is simple. We are going to chunk or divide array into subarrays. Okay, each subarray being of a certain size, and then of course there are some elements that will be overlapping, or they'll be found in one subarray and then the next subarray. Okay, so the overlap means you have elements that will be found in one subarray and also will happen to be in the next subarray. The first thing that we are going to do here is we are going to check for edge cases. The first thing is if the size happens to be less than or equals to 0. What does that mean? If the size is less than or equals to 0, or if the overlap happens to be greater than or equals to the size, then the first true value will be returned here. So here, if we happen to have something like this, then we'll just return an empty array, because you cannot really chunk something that if the number of overlapping elements are less than the size of our array, you cannot be able to do the sliding window. Okay, so all the times the number of elements must be less than or must be greater than the overlap. So having done that, let's move to the next part. So the next part is for us to look for something, the number of steps you'll be making to go to the next window. So this one will be given by the size minus overlap. That's simple. And then, of course, we want to return the const. You can have indices, which will be given by, we want now to know the starting index of each subarray. So we'll again make use of our array.from, which takes in the length, and then the length will be given by math again dot seal, and then of course we want the array dot length, and then minus the overlapping elements divided by the step, so that we can know what will be the size of the starting indices of our elements. From there, for our subarrays, from there of course we'll have now the map. So I'll make use of the map there, and then it takes in of course a callback, and then of course we want I multiplied by the step to know the starting index of each of these subarrays. So from there we just return indices.map, and then of course we'll map through each of the indices, and then every time we pass in our array and slice it from I all the way to I plus size, like that. So I hope that makes sense. Let's see, run, return unexpected comma done.